Okay, let's do some examples of separable equation. Suppose you have y prime equals to x times either 2x minus y. I want this to be plus. That's better. Okay, and our goal is to find the function y, which is a function of x, which satisfies this. Now, even after rewriting y prime as dy dx, it's not so easy to see how you can bring this y to the left side. Right? You can definitely bring this dx to the other side. And if dx is on this side, these are in the correct place, but y is in the wrong spot. I need to move this y to the other side. Do you have any good ideas how we can do this? Yeah?
Can you rewrite the e to 2x plus y as e to 2x times e to the y?
Very good. That's actually exactly the idea that you want. So you want to rewrite this as e to 2x times e to the y. That's the exponential law, right? If you have the same base and you multiply, the top adds up. Then you now see that you can bring this e to the y to the left side by dividing. So we want to divide both sides by e to the y, and also multiply both sides by dx. So dx will be brought over here, e to the y will be brought here. So if I divide, I get 1 over e to the y dy equals to x times e to 2x dx. Then what's the next step? What's the next step? You integrate, right? You integrate. Next step is you integrate. Now, to integrate this one, you really want to write it as e to the something dy. So this is the same as e to the what power?
Negative y.
Negative y, thank you. So this left side is same as e to the negative y, and integral of e to the negative y is?
Yeah.
Negative e to the negative y. I'll just add the plus c on the right side. So that's what you get on the left side. Negative e to the negative y. Now this one, how do you integrate this one?
Product rule.
Use of.
It's called a product rule if you would differentiate. Okay? It's a product of two things, right? Now this is not a use of question because this x is not the derivative of the inside function. See, what is the use of? It's the opposite of the chain rule. If you try to integrate something that was made up by some chain rule, then undoing the chain rule is exactly the use substitution. It's not of that form. If you differentiate 2x, you get 2, which is not the same as this. So this requires what?
By parts.
Integration by parts. That's what you need. You need to do this using the integration by parts. Okay. And I deliberately wrote this question down because, as I told you, if you don't review your integrals in the first week, then it will be extremely hard for you to catch up with the rest of the differential equations class. So I'm using this example so that you can refresh your integration by parts. So let's think about the integration by parts. What's the formula? It's integral of u dv equals to uv minus what?
V du.
v du, thank you. And here I'm trying to think of u as x and e to the 2x dx as dv. I should have said dv is that You know what I mean. So if you set x to be u and this thing as dv, then it's exactly this one. Now, to fill in the right side, we actually need v and also du. So first, if you differentiate, what is du? If you differentiate u, what do you get? What's the derivative of x?
1.
1. So you write what? 1
Yeah.
dx. Okay. du is 1 dx. How about this one? If you have to integrate. What's the integral of e to 2x?
2 e to 2x.
No, that's what you would get if you differentiate. If you integrate, instead of having times 2, it will be divided by 2. So it will be 1/2 e to 2x. Okay. Now we have everything to put into the right side. So the integration by parts tells us that it's x times e to 2x dx equal to u times v, which is 1/2 x times e to 2x, minus integral of v du. Du is the same as x, and v is 1/2 e to 2x dx. And that's 1/2 x e to 2x. Integrate 1/2 can be pulled outside, and integrating by e to 2x again gives you another 1/2, so it's 1/4 of the e to 2x plus c. And therefore, finally, you have the answer e to the negative e to the negative y. That's the left side, and the right side is 1/2 x e to 2x minus 1/4 e to 2x plus c. And you can still solve this for y. Let's see how we can solve this for y. E to the negative y is negative 1/2 x e to 2x plus 1/4 e to 2x minus c. And then to get rid of e, what do?
Natural log.
Take the ln, right? Take the ln of the entire both sides. You can't do this term by term. You have to do both sides, the entire thing. So that these two cancel, giving you negative y equals to this horrible thing. And then finally, if you multiply by negative, you get y equals to negative ln of negative 1/2. And then, so this will be your answer. Okay.
Professor,
Yes.
why do you change negative e to the negative y to e to the negative y for an ln? Like, why do you take away the negative there?
Oh, the thing is, this cancellation law only holds if there's nothing between the e and ln. So if I just simply take the ln both sides, then they can't cancel. See, the question is posed in a way that you want the function y. Y is a function of x. This is just the equation between x and y, so that's not what we want. So whenever you solve a differential equation, then there's a few cases where it's impossible to solve y as a function of x, but whenever you can, you should. And that means I have to get rid of this minus, this e, that minus. To get rid of all these, we have to go through all these sequences. Any other questions? All right. Now, I could just move on to the next question, but let me show you something that comes in handy. There is another formulation of the integration by parts, which is called the tabular integration. It's exactly the same thing. It's just packaged in a different way. So, in other words, anything that you can solve using tabular integration can be solved using integration by parts. Anything that you solve using the integration by parts can be solved using the tabular integration. However, tabular integration is much faster when you have to do many integration by parts. Here we just have to do one, right? But there are some questions where you have to do 2 or 3, and that does appear, especially at the end of this course. So I want you to learn this extra method called tabular integration. It's faster and easier. And I'm teaching you this because not only in this class you have to do it, but in some classes in engineering you have to do Fourier transform, and you have to do these integration by parts many times. So just to prepare you for those engineering classes, I want to show you the tabular integration. Okay. All right. So how does tabular integration work? Well, to do integral of x times e to the 2x dx, you make this table where the signs come first and d comes in the second and the integral comes last. And it's very important that you don't mix up this order. Okay? I mean, if you put integral first and d later, then it will completely mess up your calculation. So it's very important that you write it in this order. Now what you put on the first, the d's column is the function that you're going to differentiate. And I choose to differentiate x. Now, in either case, you always have to figure out what to differentiate, right? And there's something like, how does that work? Which one is it?
L-I-A-T-E.
L-I-A-T-E. Yeah, right, that's it. So L is logarithmic functions, I is
Regular?
Inverse.
Inverse.
Trig, I think.
inverse trig. Thank you. So, all right, good. So logs, inverse trigs, algebraic functions, trigonometric functions, exponential functions. So if you can categorize it, and if you write it like this, then whatever comes on the left is the one that you choose that to differentiate. Whatever comes on the right side is the one that you want to integrate. So here, x by itself, it's an algebraic function. So x belongs to the algebraic. And this one is this e to the 2x, that's an exponential function. So that belongs as an exponential function. So you want to put this as the derivative, and this one is the integral. Okay? Thank you. Yeah. All right, so I'm going to choose e to the 2x here. Now once you have chosen the functions, then what you do is you start differentiating. X differentiates to 1, 1 differentiates to 0. Now the easiest case is when you have 0 at some point. If you hit a 0, then you stop. There are cases where you don't get 0. In that case, there are some various prescriptions, and it gets a little more complicated. Okay, but we'll talk about it when we get there. Okay, so we get x, 1, and 0. We stop. Now on here, this one we are integrating, right? What's the integral of e to the 2x? They're here too. 1/2 e to the 2x. What's the integral of this?
1/4.
1/4 e to the 2x. So every time you integrate, it goes like this. On the left side, you write plus, minus, plus. You always start at plus, and the signs alternate. So that's how you fill in the table. Do you have any questions so far? Yes.
What's the plus and minus for?
That's just, actually that takes care of this minus there.
Oh, okay.
I mean, this actually just came from this one. It's just a repackaging of the integration parts. Okay. All right. So now what? Once you have filled in the table, this is what you're gonna do. Imagine two sides having a war, and this side has lots and lots of missiles, okay? And they're gonna shoot the missiles, right? Just like that, right? Okay. And then there's no more. Okay. If it can't fall down, you don't shoot anymore. And whenever this goes, the missile should always go in this direction. Okay. It has to be in this form. And what you do is you multiply everything. So it's positive x times 1/2 e to the 2x. So it's 1/2 x e to the 2x. This one, negative times 1 times 1/4 e to the 2x. So it's negative 1/4 e to the 2x. And the other side, who is not so powerful, they only have a single bullet. That's it. Okay. This last line, you multiply and you have to integrate that thing. Okay? Now here, if you multiply everything, that's 0, right? And if you integrate 0, you get C. That's where you get the C. And you add up everything, you get exactly the same result, right? You see that? You get the exact same result, right? So right now it may not seem that convincing because it still seems pretty complicated, but once you try to deal with questions where you need many partial integration by parts, you will see that Tabular is much more stronger. Yes?
Now, how does the ln go with the Tabular? Is there no ln?
No, ln was something that we did to solve for y.
Okay.
The integral should
Oh, I see.
just gives you that much. Okay. Any other question? Yes?
What do you do for that last line?
You multiply and you integrate.
Oh, okay.
You have to multiply and integrate. Now, the thing about having a 0 is that that means you're integrating 0. The antiderivative of 0 is just constants, because constants differentiate to 0, right? So that's the easier part. But there are some cases this last line actually do give you some other terms.
Nope.